All right, Assalamu alaikum. This is Faisal Abbas here. In today's video, we're going to be doing some basic storage operations. We're going to be creating EBS volumes and then attaching them and detaching from Windows and our Linux instances. The volumes are, for the basic sysadmins, it is the disk that we are going to attach to our Windows and attach to our Linux instances. So let's log into the console. I am logged into the console here. You see that I am the basic operations, basic information. Logged in with my root account. My default region is North Virginia. So I'm in the AWS Management Console. I'm gonna click on EC2. And here in EC2 dashboard, you see that I have two instances running. I have already created two instances. One is Windows and another one is Linux. Basic instances, nothing fancy, nothing customized. And so before we go into the into creating the volumes, we need to make sure that the volumes or the disks which we are creating and going to attach to our instances, they need to reside on the same availability zone. So our Windows and Linux, they both are at this time currently residing in US East 1A AZ. So we're gonna make sure that when we create our volumes, they need to reside in the same. All right, so on the left-hand side under the EC2 dashboard, scroll down here and you see that Elastic Block Store or EBS. Under that, you see the volumes. So I'm gonna click on volumes. You are seeing two volumes already created there. These are for our OSs for Windows and Linux respectively. So I'm gonna click on create volumes here. Once I click on create volume, so there are different types of volume types available here: general purpose, provision, IOPS, cold or throughput, optimize or magnetic. Let's just pick general purpose SSD, and I'm gonna so there's a minimum of 1 gig, so I'm gonna just pick 1 gig here. And availability zone, it has to be the same, otherwise cross AZ volume attachment is not available at this time with AWS. Up to you if you want to encrypt the volume, and you can encrypt the volume and then pick the master key. Amazon provides the master key as well, the default master key. If you want to encrypt the volume, that means that the data is encrypted when it's rests on the disk. Okay, so let's just not encrypted and then add the tag. Let's just name it as Linux data. So it'll be our, we're gonna mount in Linux as our data drive. All right, so I'm gonna click on create volume. A volume is created successfully. This is the volume ID. So I'm gonna click close here. So we have the volume created for Linux. Let's just create one more. And this time I'm gonna pick, let's say magnetic storage, or maybe a cold storage. So for the cold, the minimum is 500 gig in size. So we'll just pick the minimum. AZ is the same, 1A. All right, so encryption and the same thing. So let's just name it as, give it a tag as name, cold data. You can name it whatever you like it, okay? All right, so I'll just click on create volume here. Volume is created successfully with a unique volume ID. Close here. So now we have two volumes already created, okay? All right, so let's just go ahead and attach these volumes to our Linux machine. So highlight the first one, Linux data, go into action, and then attach volume. When you go to attach volume, it's gonna ask for the instance ID or instance type. So remember, we already have two instances created and we provided the tag to them. You see that Linux is the tag for the Linux machine and Windows is the tag for the Windows machine. So we're gonna pick Linux here. Device type, it picks up the device type, whatever the next available letter is. Linux goes with /dev /SDF or SDA or SDB. And then in the OS, you will see it actually goes through with, slash dev slash xvdp, xvda, xvdd, or whatever the lettering is. So pretty straightforward. Click attach here, and the volume is being attached to our Linux instance. All right, so I'm gonna, by the time it is being attached here, so let's scroll up and let's go into our EC2 dashboard, and you see that our 2 instances running, and now the number of volumes is 4 since we created 2 additional ones. All right, so I'm gonna click on running instances, and we'll connect to our Linux instance. I highlighted that. We'll pick the public DNS IPv4. I'm gonna go to my Putty here, and then inside the Putty, I'm gonna just pick the EC2. I'm sorry. So we already have the EC2 user populated, so I'll just paste it the username here, and under the SSH, I'm gonna click on auth and validate. Yes, my key is. I'm gonna have to pick my key, so I have in under the folder my Linux pvk. This is the key I used to create that instance. I'm gonna click open. First time warning, and now we are connected to our Linux instance. All right, so now we are connected to Linux instance. So let me just sudo myself to root. You see that the prompt is changed from $sign to the pound sign. All right, so let me just increase the size a little bit here for you guys, and increase the font real quick. Go to window, under Windows appearances, click change here, and I'll change the size to 20. All right, click apply here. All right, so it must be readable for you guys now. Okay, all right, so I am root here. Clear the screen. All right, so how do I find out that the disk is there? So there is a command to listing of the blocks, because these volumes are being presented to Linux as a block device. So lsblk, list block command, and lsblk, it is showing me that we have one xvda already there. Xvda is, it has a partition created as xvda1, and that is mounted as /, which is mounted as root partition where the OS is installed. We also have another disk xvdf. The size is 1 gig, and it is not mounted at this time. Okay, so now what we're gonna do is we're gonna be doing 2 different type of operations. One is we're gonna go through the LVM operations, and the another one is just simply formatting and then mounting it directly. All right, so disk, let's just find out how is the disk currently being set up here. So right now we have xvda1 disk, which is 8 gig in size. 1.3 gig is used, 6.8 available, like 16% is utilized, and it is mounted as /. So all the file system is mounted under that. So we do not have any LVM configured here. LVM stands for Logical Volume Manager. So how it helps out is when you have, let's say, a set size of a disk, you create the LVM, and then when it gets filled up or close to filling up, then instead of creating a new volume, if you have the LVM, you just attach a new volume to your instance, and then that volume you assign to that LVM, so it will automatically increase the size of the existing LVM or the logical volume manager. All right, so there are a couple of commands for that. 3 commands which you need to understand. One is the physical side, second is the volume group side, and the third is the logical side. So PV, VG, and LV. So PVS, it is showing that we do not have any physical volume currently configured. And if you see that we have a blank disk available, xvdf. So what we're gonna do is we're gonna create a disk, bring this volume into the PV. So pvcreate /dev. This is how the device ordering goes in Linux. /dev/ and I'm gonna paste it xvdf. All right, so it's saying me that it is it has successfully created the disk. All right, so if I do it again, PVS, I see that I have a disk that is LVM, that is size of 1 gig, and it has 1 gig physical volume free. So it is not used at this time. Let's just run this lsblk command again. All right, so it is still showing the disk is available. It's not mounted yet. Okay, now we perform the PV part. Now we're going to perform the VG part. Okay, so when I do the VGS command, it is showing me blank. Okay, so I'm gonna vgcreate volume group create on top of this physical volume. I'm gonna just name it as it's a volume group for my data, and I'm gonna pick the device slash dev slash, remember it is after the PV, it gave me the device lettering SDF, so SDF. Okay, so now that I do perform that, volume group created successfully. Okay, now if I do a VGS command, it is showing me that there is a volume group created out of that one PV. There is no logical volume underneath it. These are the attributes. This is the size, and the entire size is free. So our second step of a VG is complete. Now we're going to do the third step, which is the logical voluming. So we're going to create a logical volume on top of this volume group. All right, so couple of commands here. So let me just run the lvs command, logical volume show. There's nothing there at this time. So I'm going to run the lvcreate, and I'm going to name it as logical volume of data, lv underscore data. This is what I named it. And then I'm going to give a size of, I wanted to use the entire, so dash L, so it is for the sizing. And I want to use the entire disk. So I'm going to just pick this 1020 meg. Okay. And where I am creating it from, I am going to creating it from volume group, which is vg underscore data. Okay. All right, so it is giving me that VG is created. So if I run the LVS command again, now it is showing me that this is the volume group LV underscore data out of, sorry, this is the logical volume LV underscore data out of volume group VG underscore data. These are the attributes. This is the size and the rest of the information, which is all black at this time, you know, all the metrics here. Which pool is from, original data, percent meta, percent, and all that. Okay, so volume group is created. So now we have performed all three of our operations, the PV operation, the VG operation, and the LV operation. Now I'm going to have to do is we have to mount this disk somewhere, right? So that it will be accessible by the Linux operating system. All right, so I'm going to create a directory, persistent directory, and I'm going to name it as /data. Okay, so slash means that it is part of the root partition because remember we created this disk to store our data, or let's say you want to store your backup or whatever application data or whatever whatnot. All right, so we created the directory. Now, if I do a lvdisplay command, I'm doing the lvdisplay command. It is showing me that this is the lv path, this is the lv name, and then out of which VG it is part of, what is the UUID, and how it was created, creation time, availability, and all those details are there. Okay. All right. So what I'm going to do is I'm going to pick the LV path here. It is showing me that if I go reverse here, so this is the logical volume on top of the volume group on top of that physical disk. Okay. Now we have to format this, otherwise we will not be able, it's still a raw disk, so we have to format it so that Linux will be able to understand that what formatting we have used, so that it'll be able to access it. All right, so to format in Linux we have the command called make file system, or mkfs, and then there are different types of file systems. Currently extended for is in use. Or if I just remove here, remember Linux has a tab completion, so I'm going to have it here. So it is giving me option of extended 2, extended 3, or extended 4. Let's just pick extended 4. And then since I highlighted, selected already, I pasted in here. All right, so it is, okay, let me highlight it here for you guys. Okay, what it did is after I hit enter, created the file system, gave it a label, OS type, block size, and all those, details, and all the tasks are completed. So the disk is formatted. Now we can use it. So now what we're gonna do is we're gonna mount this disk and we're gonna, utilize that. So let's do a lvs command. It is showing me everything is there. vgs command is showing me everything is there. So lvdisplay command showing me that it is there. It is it is not mounted at this time. Let's just go back and let's find out lsblk command, the first command we ran. You see that here now that we have a disk that has a volume group created and attached to the logical volume. This is the size and the type is a LVM, not a disk, not a partition, but it is not mounted yet. Okay, so what I'm gonna do is I'm gonna mount this disk to the /data mount. Okay, type this command, put the data there. So if I run the lsblk command again, you see that this disk now it has a mount point which is /data. All right, so right now pwd I am under the /root or root home folder. So I'm going to go to /data, and if I do a ls-l, I see that there is it's just one lost and found folder there. So I can create any file, or I can create any directory, let's say some test. And if I do ls-l again, so you see that disk is accessible. It is usable here. So this is how we perform the operation in our Linux machine. Okay, now that the disk is attached, what if we wanted to remove this disk and then let's say we want to terminate the instance, and then we want to preserve our data, and then we want to use it afterwards, maybe to some other Linux instances. The best policy or best practice is to unmount it cleanly, and then detach it from the AWS console. All right, so here what I'm gonna do is so the disk is here already. I am in the directory. If I do a pwd, I am under the directory, so I have to come out of the directory, and then you issue the umount, which is unmount command. And when I'm unmounting, I am unmounting the mount point, so it is unmounted. If I do it df again, it should not be there. See, the data is not there anymore. So that means that the disk is unmounted. Since the disk is unmounted, so what we're going to do is we're going to go to our console here under the volumes. If I click on volumes here, remember there's a Linux data. So what I'm going to do is I am going to highlight that, and then I can detach that volume. Yes, confirmation for the detach. It is detaching right now. By the time it's detaching, let me just run the lsblk command to validate. Right now you see that the disk is still there. Once the detach completes, the disk will be removed from there. So by the time it is being detached, let's just do one thing. Let's just pick this cold data. Remember the 500 gig one which we created. I'm going to go into the it's going to take some time. All right, let's just refresh it here. Okay, so I highlighted the cold data, and I'm gonna go and attach that volume. So before I attach it, let's just do one thing. I'm gonna go back into the Linux, clear this screen, and then I'll provide the command again, lsblk. It is still shown there, but it is not accessible anymore. All right, so what I'm gonna do is I'm gonna attach that volume, this 500 gig cold one which we created. I'm gonna attach it to the Linux. It is attaching right now. See that the attachment information, it is attaching. Let's just refresh it here. It is attached, shown as dev sdg. Right, so lsblk again. lsblk again, it is showing us a new disk xvdc 500 gig in size, and this is the disk. Okay, so previously we performed the lvm operation. This time we're gonna just simply format this disk and attach it as a disk or as a partition to our Linux. Okay, so for that, it's just pretty straightforward process. We'll just simply make fs standard for /dev/xvdg. Let's see how it goes. So it is doing its work. Give it some time, and it's gonna, since it's a bigger size disk, 500 gig, it completed the work. Now the disk is formatted. I can simply, without the LVM, I can simply just mount it. Remember, okay, so let's just create one mount point. So mkdir -p persistent disk directory. Let's say we name it as cold data. Okay, now I'm gonna mount /dev/xvdg. I'm sorry, under /cold data. Okay, if I do a df hpt, you see that it is mounted there. Size is 439 gig. So 500 gig is the raw size after the formatting. It used about 1% of the disk size. And then now that we have available is 467 gig of the disk space. So if I go to this directory, and I can perform anything here. I can, let's say, make dir data, or let's say copy some file from more log messages file here. All right, so I can copy, I can do whatever the operations I can. All right, so this completes our video. In our next video, we're gonna do the similar operation on our Windows machines. All right, see you guys in our next video. Thank you.